Okay, so what we're going to look at in this lesson is something called gradient. Now, when you think about going up a hill or a mountain, so let's say draw an example. Let's say this is some sort of a hill, and let's say this is some sort of a tall mountain. Okay, there's a big difference in a number of ways. Okay, there's two things that are on this drawing. They're meant to represent this idea of steepness. Now, in mathematics, we don't really use the word steepness because in English you can say something is sort of gradually or slightly steep, or you can say very steep, but these don't really give you an idea of how steep something is. I mean, obviously when you look at the steepness of the hill, it becomes steeper as you go further up. And the same thing for the mountain. The only thing is, with the mountain, once you get up here, it's very steep. Now, what you'd like to know is, when you look at the steepness up here, and you want to compare it with the steepness there, is there a mathematical way to compare the steepnesses? Or if you want to compare the steepness here with the steepness here, how do you do that? Well, what you do is you use something called gradient measurement. So you need to work out the gradients of those lines. Each of those lines that I've just drawn have gradients. So we could say that line has a gradient, that line has a gradient, this one has a gradient, and this one has a gradient. You could probably say, in order, gradient 4 has the highest gradient, and the lowest one is gradient 1. Okay, and the others are in between. So obviously, 3 is less gradient or gradient than 2. So you could say something like that. Gradient gets higher this way. But you want to be able to put numbers, measurement to this idea of gradient. There's a way to do it. And so the way you measure the gradient of a slope, and in this situation, we're talking about this particular slope here. So imagine driving along that slope there. Okay, that slope is not as steep as this one. Okay, so this second one is more like the mountain, and the first one is more like the hill. Now the way you do it is you look at the two shorter sides. You look at the vertical side, and you call this side rise. You look at the horizontal side. This is a right angle triangle. So this is the horizontal side. We call this side run. In each case, what you do is you're comparing these two sides. So let's say you got out a ruler and you measured the rise here to be 3 and the run here to be 5. Well, your gradient measurement is your value of rise over run, or rise divided by run. And it's 3/5. Go to your calculator, you'll find that out to be 0.6. Now instead of writing gradient down, we often use this symbol, M. m is the same as gradient. So you can say that this gradient here has a value of 0.6. Now the next one, let's say this one here has a rise which is a little bit higher. Let's say it's 5. And let's say the run is 3. So in other words, it's the other way around. Well, you'll do exactly the same thing. Gradient is always the vertical distance, which is your rise, divided by your horizontal distance, your run. And in this case, it's 5 divided by 3. Now you can work that out. You can say 1 2/3, or you can say 1.67, corrected 2 decimal places. Now if you compare these, that's 0.6. This one here is 1.67. They are significantly different. This is over twice the gradient. It's almost twice as steep than the original one here. Okay.